Let f of x equal x cubed plus 6x squared minus 9x minus 54. We're told here that x equals -3 is a zero of the function, and we should use the factor theorem to completely factor the polynomial. And by completely factor, we mean linear factors. So using the factor theorem, this is my version of it. X minus k is a factor of the function if and only if f of k equals 0. In other words, if the number k, when you plug it in, is a 0, like they say x equals -3 is a 0 of the function, and you can test this. You can plug in -3 for all the x's and evaluate and see that it gives you 0. So being that -3 is a 0 of this function, it should be true that x minus k is a factor of that function. So now we know that x minus -3 is a factor of the function. That can be simplified to x plus 3. And so what this means is that when we divide it into the greater polynomial, we should get a remainder of 0. And we can use synthetic division for this. Now, notice that this is my factor, but this was the 0. So we're going to do -3 and synthetically divide the coefficients of the polynomial in descending order without skipping any. So the coefficient of x cubed is 1, the coefficient of x squared is 6, the coefficient of x to the first power is -9, and then the constant is -54. So using synthetic division, we drop down the 1. -3 times 1 is -3. We get a remainder of 3. Then -3 times +3 is -9. That gives us a remainder of -18. And then +3 times -18, what is that going to give us? It's going to give us a positive number because it's a negative times a negative. 3 times 10 would give us 30. 3 times 8 would give us 24, and 30 plus 24 is 54. Yay, we get a 0 remainder as we expected, since we know that -3 is a 0 of the function. Great. So now we can take these numbers at the bottom row here and use those as coefficients to a new polynomial that is 1 degree lower than the original. And why is this useful? Because now we can rewrite our function f of x as the factor x plus 3 times, use this as the coefficient of the x squared term, 1x squared, then plus 3x to the first power, and minus 18. Okay, so this is nice because we have partially factored our polynomial, but we want to continue to factor it until we have all linear, all powers of 1 on the x's, all linear terms. So luckily, we know how to factor quadratics. So this one is nice because we only had to do synthetic division once, and now we will just use the skills we know for factoring a quadratic polynomial. And so hopefully from previous lessons, this part is just a review. And what we see is a -18 as the last term. So we know we're going to have one of each sign here. And we know that we want two numbers that multiply to give us -18, but add up to give us +3, the middle coefficient. So I start thinking about all the ways I can multiply two numbers to get -18. And let's see, 3 times 6 has a difference of 3. So I'm going to do 3 times 6, but I'm going to give the larger number the positive because my middle term is positive. And so now I have factored the original polynomial completely. And to check if this is correct, you can just multiply everything back together and make sure that it gives you back the original.